This is round 2 of taking the chop of a linear function and trying to find the slope if it's not the partial derivative with respect to x and it's not the partial derivative with respect to y. Just a little tiny reminder, if I want to find the partial derivative with respect to x, what I do is I take a chop like that, right, and we go from this point over to the next contour line, and we measure delta z over delta x, and that's the slope. And that's the partial derivative with respect to x. If I wanted the partial derivative with respect to y, I make a chop like that. I go from this point to the next nice point on the contour, and I calculate delta z over delta y. But what we did in GeoGebra, we took a slanty chop, something like a chop that looks like, I think, this over to this point. Now, when you take this kind of chop on a plane, we saw that that's a line and it has a slope. How are we supposed to calculate that? Well, this still is rise over run. For example, I think the z value on this contour is 4. I think the z value of this is on 11 because they're going up by 1. So the delta z is just going to be the change in the z values from this point to this point. But the distance isn't delta x anymore, and the distance isn't delta y anymore. It's actually this slanty distance, which is actually going to be the square root of delta x quantity squared plus delta y quantity squared. So we're going to get a more complicated slope to calculate, but it's something we can calculate. What we're going to do now is go over to the whiteboard, draw the same picture, make that calculation, and draw some conclusions.